Imagine waking up tomorrow, grabbing your coffee, and you're just reading the news.
Just a totally normal morning.
Yeah, normal morning. But then you find out your city's government has just decided to run its entire transit system and public utilities actually on a completely new, untested artificial intelligence.
Oh, wow.
And not like a small pilot program in one neighborhood. I mean, the whole thing, like they changed the local laws overnight, bought thousands of servers by breakfast, and they just expect the whole system to be fully operational and running your life by Friday.
I mean, that sounds like pure science fiction for most of us.
Yeah.
Because, we are used to cities where fixing a single pothole takes, what, 3 years of committee meetings?
Exactly. A bike lane is like a decade-long battle. We just expect cities to be natural, messy, and above all, incredibly slow.
Right.
But what if a city wasn't built through that slow evolution? What if it functioned more like a blank hard drive where massive new civilizational upgrades are just downloaded and installed?
Installed like an operating system.
Yes. And that right there is the exact mission of our deep dive today. We have this really fascinating stack of analytical sources in front of us, and we're going to use them to examine exactly what is happening in Dubai.
But we should probably set some ground rules for you, the listener, right out of the gate.
Oh, definitely. Let's be clear. We are not here to talk about tourism.
No.
We are not doing a segment on the tallest skyscrapers or the luxury stuff or futuristic architecture. And we are definitely not here to act as a PR machine for any specific technology.
Which is so vital, because to really understand the source material today, we have to stay entirely objective.
Right.
We're looking at this purely as a mechanism. We aren't here to praise their ambitious goals, and we aren't here to critique their political methods either. The goal is just to systematically unpack how this specific urban environment actually functions underneath the surface.
Because calling Dubai a city of the future is, well, it's completely insufficient.
Yeah, the sources actually argue that it's a lazy shorthand.
A lazy shorthand. I love that phrasing. It completely misses the actual mechanics of what is happening on the ground there. So instead, we're going to explore a much more precise, frankly, much more fascinating definition. We are going to look at Dubai as an orchestration node.
And if we want to truly grasp what an orchestration node is, we have to aggressively ignore those surface-level decorations that distract most observers.
Okay, let me push back on that a little bit, or, at least play devil's advocate for a second.
Sure, go for it.
When I hear City of the Future, my brain immediately goes to those visible outputs. Like you see the autonomous mobility initiatives on the news, the AI-driven government services, the massive global finance hubs. So why are the sources calling those massive things just decorations?
Because they are the result, not the engine. I mean, think about a typical city. A new industry like artificial intelligence emerges organically, right?
Right. A few startups form in a garage somewhere?
Exactly. They form, they attract some venture capital, they bring in talent, and then that talent eventually demands housing, and the new housing puts pressure on public transit.
And then maybe a decade later, the local government finally catches up and passes some zoning regulations to accommodate it all.
Precisely. The market moves first, and the city reacts to it. But an orchestration node operates fundamentally differently. The defining feature of Dubai isn't the AI itself. It's the city's structural ability to deploy that new civilizational function directly into its urban operations.
So it's forcing the environment to adapt instantly.
Exactly. It's not waiting for the market to decide what happens.
So, and I love a good analogy. If cities are software, Dubai isn't actually trying to write the original code. It is providing the ultimate hardware, like the optimized motherboard, to run whatever code is currently the most powerful.
That is an incredibly useful way to visualize the mechanism. And we can see this dynamic perfectly if we contrast Dubai with a city like San Francisco.
Right, because the sources draw a very sharp distinction here. They classify San Francisco as a direction node.
A direction node, yeah.
It's a place where you have founders, university researchers, venture capitalists, and massive tech corporations all mashed together in one geographic area, and they're generating multiple competing possible futures.
Throwing 100 different versions of the future at the wall.
Exactly. Social media, crypto, VR, AI, they're just seeing which one actually sticks. They create the direction of the technology.
But an orchestration node does not need to generate countless possible futures. Its core function is to look at the directions developed elsewhere, like in San Francisco, select the most viable one, and then convert that selected future into a concrete, implementable structure.
So direction creates the possible futures, but orchestration converts a chosen future into reality.
Exactly.
It takes that abstract technology and connects it to the capital, the legal institutions, the global talent pool, and the physical infrastructure needed to actually run it at scale.
And this is where we really have to look at the underlying logic of the money involved.
Yeah.
In an orchestration node, capital and institutions aren't just reacting to market signals.
Right.
They are the initial conditions placed firmly on the board before the market even begins to operate. Capital here acts as a deployment tool.
A deployment tool.
Yeah, it's not a standalone investment simply seeking a quarterly financial return. It is a blunt force mechanism used to force a new urban structure into existence.
But wait, I need to make sure I'm getting this right. If a government is pouring billions into an AI infrastructure, aren't they doing that to make a profit down the line? I mean, how is deployment capital really different from regular investment?
It's about the breadth of the synchronization.
Okay.
Think about a traditional venture capitalist. They invest in an AI company so that company can sell software. But when an orchestration node uses capital, it isn't just funding the company. It is simultaneously synchronizing the national power grid to support the compute load, rewriting the national data privacy laws to allow the AI to train,
And overhauling the visa requirements to instantly import the engineers,
Exactly. The capital is buying total environmental alignment.
which is a staggering amount of power to coordinate all at once.
Yeah.
But, that brings up a really crucial distinction in the reading. Because when we talk about all this massive state capital and centralized strategy, I realized I was making a huge geographic mistake early on.
Oh.
Yeah, I was blurring the lines between the city and the country.
Oh, right. It's a very common analytical error.
Yeah.
How did the sources help you distinguish Dubai from the wider UAE state system?
Well, they pointed out that Dubai is not identical to the entire United Arab Emirates.
Right.
When you look at the really heavy foundational elements, like the massive national sovereign wealth, the advanced compute access, the broad security policies, and even the international diplomacy required to secure microchip supply chains, those are distributed across the broader state system.
Yes.
A huge portion of that foundational power actually sits with Abu Dhabi, not Dubai.
Precisely. Abu Dhabi and the wider UAE state operating system provide those deep structural resources. Dubai, then, serves a highly specialized function. It acts as the conversion surface.
A conversion surface. I found that term to be the absolute key to unlocking this whole concept.
It's a great term.
Right. Dubai takes those massive, abstract national resources, say a diplomatic agreement with a foreign nation for technology sharing, backed by sovereign wealth, and channels them directly into the pavement.
It converts them.
Exactly. It converts them into real companies, global finance operations, public administration, and the private economy. It makes the abstract policies completely tangible.
But how does that conversion actually happen? Because, it doesn't happen by magic.
Nope, definitely not.
The sources break down this orchestration process into 5 very distinct stages.
Yeah, and reading through those stages really demystified how this download actually hits the ground. But honestly, when I first read the outline, it sounded a bit like a corporate textbook.
A little dry, yeah.
Yeah, so they start with what they call selection. So the state apparatus decides what specific function needs to be adopted. They pick AI, for example.
Right.
But picking a goal is easy. Every city has goals. How does selection actually translate into reality?
Well, that requires the second stage, which is alignment. This is that mechanism we touched on earlier. Once the target is selected, you don't just ask the market to figure it out.
You force it.
Exactly. You direct all available capital, institutions, and talent toward that exact specific objective. You change the visa rules overnight to bring in the specific engineers you need. You allocate prime real estate for their headquarters.
You set up aggressive financial incentives.
Right. And you eliminate all administrative friction that doesn't serve the target.
Yeah.
Every single vector of the city is pointed at the selection.
Okay, so you've got the money, you've got the visas, you've got the engineers landing at the airport. Then comes the third stage, which is deployment. And this is where I think it gets genuinely wild.
It really does.
Because deployment means introducing this selected function into real, breathing urban operations. To stick with the AI example, it means AI is no longer just a standalone tech sector that the city is trying to grow in some business park.
No, it becomes the mandatory background operating system of the city itself.
Yes. It starts handling traffic lights, it handles government administration, it allocates public resources.
You aren't just inviting companies to rent office space. You are forcibly integrating their product into the daily lives of the citizens. But, that aggressive integration immediately triggers the fourth stage.
Which is maintenance.
Exactly, which is far more complex,
Yeah.
sustaining this newly deployed structure over time.
And what happens when things inevitably break? Because pushing a massive software update to a physical city overnight is going to cause some crashes. I mean, the new AI traffic system might accidentally route every delivery truck into a narrow alleyway.
Right.
How does the city handle that?
Well, that requires the fifth and final stage, resynchronization. This is the system's ability to take the emerging differences, the failures, the unexpected delays, and the friction generated by the deployment, and return those data points to the central operating system for adjustment.
Which honestly seems like the hardest part. Because rapid deployment, like forcing things to happen fast, is absolutely not the same thing as long-term maintenance or correction.
Not at all.
It's one thing to build a massive infrastructure project in record time. It's another entirely to realize 3 years later that it's causing a massive systemic failure and you have to completely rewrite the policy.
And this raises what might be the most important question of our entire analysis. Is rapid implementation always a sign of strength?
Ooh, that is the question.
Right. We look at the speed of an orchestration node and just assume it implies total capability.
Right.
But where do the differences and the costs created after that deployment actually go?
Okay, this is the part of the reading that really forced me to change my perspective because the sources highlight what they call a velocity mismatch. And to me, this is the absolute center of gravity for this whole deep dive. You have fast-moving layers of a city, and you have incredibly slow-moving layers.
The fast-moving layers are the abstract constructs we've been discussing. Capital allocation, policy changes, building permits, diplomatic agreements, technology procurement.
The paperwork, basically.
Exactly. A highly centralized system can synchronize these almost instantly. A decision maker can sign a check for 10,000 DPUs and change a national visa law on a Tuesday afternoon.
But then those fast decisions hit the slow-moving layers, the physical reality of the planet.
Yeah.
Electricity, water. Let's look at cooling those data centers, for instance.
Yeah.
You're in the Middle East, a high-heat, water-stressed environment. You have to physically cool the servers running this new deployed future.
Which is incredibly resource-intensive.
Exactly. That requires massive amounts of power and desalinated water. You can sign a check in a minute, but building a desalination plant requires environmental assessments, physical pipelaying, and sheer thermodynamic energy.
And it doesn't stop at physical resources. What about housing for the thousands of workers you just imported?
Right.
What about the years it takes to retrain the existing local labor force so they aren't completely left behind? What about cultural acceptance or internal business accountability?
These are the material realities of human existence. They are bound by physics, biology, and sociology. They simply cannot change instantly, no matter how much sovereign wealth or aggressive policy you throw at them.
So Dubai's unique, incredible strength is its structural ability to compress the delay between these fast and slow layers. They can force the physical world to catch up faster than almost anywhere else on Earth.
Yes, and there's a big, but here, there is a profound vulnerability built into this exact strength.
There is.
When you compress time, the resulting friction and the costs of that speed don't just magically disappear. I could think about this while reading. You literally cannot delete friction from a system.
You can't. Instead, that friction reappears in hidden places, gets absorbed by the slower layers of reality.
Meaning the people and the physical infrastructure.
Exactly. It burdens the mid-level companies that are suddenly trying to keep up with dizzying overnight regulatory changes. It heavily stresses the labor force that is constantly being forced to adapt to new operating systems without sufficient time to learn them.
Wow.
It strains the physical resource systems, like the power grid might hold, but at what hidden maintenance cost? The water supply is pushed to its absolute limit. It warps the daily urban living membrane. The true cost of speed is always paid by the slower layers of reality.
It makes me think of a systems analogy. It's like trying to run a high-frequency stock trading algorithm on a 1990s dial-up modem.
Oh, that's a good one.
Right. The algorithm is the policy. It wants to execute 1,000 trades a second, and it's perfectly designed to do so. But the physical copper wire of the modem can only process 1 trade a second.
So the pressure builds up.
Exactly. The algorithm doesn't just cheerfully slow down. The system either crashes, the wires overheat, or you start losing massive amounts of critical data in the bottleneck. The friction has to go somewhere.
That is an excellent visualization of a velocity mismatch, which forces us to ask an uncomfortable question about urban design. What becomes secondary or even expendable when a city synchronizes too quickly?
Now, hold on. I want to be entirely fair to the source material here because the authors are very clear that speed itself is not the enemy.
No, not at all.
Rapid synchronization has massive, undeniable advantages in a global economy. You get shorter translation times between different institutions, you get highly concentrated initial investments that can build coordinated infrastructure without suffering through decades of bureaucratic red tape.
You dramatically lower the friction for launching entirely new industries.
Absolutely. Speed is a formidable weapon in global urban competition. But the core issue identified in the analysis isn't the speed itself. It is a question of detection.
Right. Can the differences, the bottlenecks, and the human frictions that emerge after deployment be detected and actively returned to policy, capital allocation, and urban operations?
Basically, can the system tell that the dial-up modem is melting?
Precisely. If a new AI-driven administrative policy rolls out overnight, but it causes utter chaos for small business owners trying to file their quarterly taxes, does the central system detect that chaos?
And more importantly, does it actually adjust, or does it just push forward?
Exactly. And this brings us to a vital concept in the text: multi-velocity operation.
Multi-velocity operation. I struggled with this term at first, I'm not going to lie, but it makes perfect sense once you apply it to the friction problem. Walk us through how a city actually does this.
The premise is that a sustainable orchestration node cannot force every single actor, every massive corporation, every small business, every worker, every residential neighborhood into the exact same timeline of adaptation.
Because if you do,
If you force total synchronization, you will break the social and economic fabric of the city. To survive long-term, the city must deliberately preserve different paths.
meaning it needs to intentionally engineer buffer zones. It needs to allow for different speeds of adaptation.
Exactly. It needs hyper-fast paths for the early adopters who can pivot immediately, but it must also preserve paths for those who need to connect to the new system later. It needs paths that remain temporarily paused, allowing for observation. It needs paths that allow for recovery after a fast deployment fails. And crucially, it must preserve paths that return complex decisions to human judgment, rather than relying entirely on the newly deployed automated synchronization.
So it's not just this ruthless environment of adapt instantly or perish. It's recognizing that a healthy urban ecosystem requires completely different operational speeds to function.
Right.
If you try to force the physical infrastructure or the local workforce to adapt at the exact same speed as a billion-dollar capital transfer, you just end up breaking the workforce and the infrastructure.
And broken infrastructure doesn't generate a return on investment. If we connect this back to the bigger picture, the hidden vulnerability of a hyper-fast orchestration node is that in its pursuit of efficiency, it might accidentally optimize away the very safety valves and slow lanes that make a city livable, resilient, and capable of long-term survival.
Wow. So what does this all mean for us? I mean, how should you, the listener, look at cities after understanding this framework? To me, it completely reframes how we judge urban capability.
It does.
When we look at a rapidly developing city, we shouldn't be asking, wow, how many massive futuristic systems can they deploy at the exact same time?
Because that is the old metric of success. It focuses purely on volume and speed.
Right. The new metric, based on the deep analysis in these sources, is asking how well can the city preserve the connection between systems that are forced to move at completely different speeds? Yeah. Can the city keep its hyper-fast AI deployment safely connected to the slow physical reality of a water desalination plant and the deeply human reality of a worker who needs 6 months to retrain for a new job?
That ability to resynchronize the fast and the slow, to detect friction and manage the velocity mismatch, is the true ultimate test of orchestration. Without it, a city might look futuristic, but structurally, it becomes incredibly brittle.
It's a profound way to look at the world. And taking this new definition of a successful city, I was fascinated by how the sources zoomed out at the end to look at the global ecosystem.
Oh, yeah.
Because they don't just look at Dubai in isolation. They map out a whole network of global cities acting almost like different organs within a single civilizational body.
It's a highly effective comparative lens. It shows how dependent these urban functions are on one another.
So we talked about San Francisco earlier. In this global body, San Francisco is the organ of direction, constantly generating and discarding multiple possible futures.
Right.
Then you look at a place like Northern Virginia, which the sources highlight as the organ of computation. It is physically supporting the massive data centers, the cooling grids, and the hardware needs of the global internet.
Then you examine Singapore. It acts as the organ of circulation. It doesn't necessarily generate the tech, but it excels at controlling the secure flow of logistics, raw data, and global finance across international boundaries.
Then you have Tokyo, functioning as the organ of synchronization. Not rapid orchestration, but aligning massive corporate conglomerates, complex layers of government, and a dense, aging society across a massive, long-term time axis. It's a slow, meticulous, but incredibly deep synchronization.
The sources even briefly mention Sapporo up in northern Japan, which exposes the absolute physical limits of life maintenance, demonstrating how a city must battle intense climate and heating constraints simply to keep human civilization physically viable in a hostile environment.
And then you have Dubai, the orchestration node.
You orchestrate.
Exactly. The city that essentially bundles all these external capabilities together. It imports the direction from San Francisco, relies on the compute models pioneered in places like Northern Virginia, utilizes the capital flow mechanisms of Singapore, and then converts them all via the UAE's massive sovereign resources.
It takes all those separate organs and forces them to work together in one place, rapidly deploying them into a single, synchronized urban operating surface.
Which leads us to the ultimate conclusion of the text. It is not a city of the future. It is the city that deploys the future.
The city that deploys the future. That perfectly captures the mechanics we've been unpacking today.
It really forces us to ask entirely different questions about what makes a city structurally successful in the 21st century.
It absolutely does.
Well, I want to thank you, the listener, for coming along on this deep dive with us today. We covered a massive amount of ground, from software analogies and dial-up modems to the hidden physical costs of desalination plants.
We really did.
But before you take off your headphones, I want to leave you with one final, lingering thought to explore on your own.
Go for it.
Think about your own city. Think about the streets you walk down every day, the local government, the industries that surround you. Is your city a place that generates the future, throwing chaotic ideas at the wall? Or is it a place waiting to orchestrate it, preparing the hardware for the download? And when a massive new civilizational function, whether it's AI or autonomous transit, or an energy grid we haven't even named yet, is finally downloaded into your neighborhood, who exactly gets to decide the speed at which you are forced to adapt?